So, I would like to now call on stage Michel Fayal, who is, I must say, one of the other major engines of the work that has been done in IFAFRI. Without, I think, all the effort that you have personally put in this endeavor, it would not be where it is right now. So, before even giving you the floor, I would like to thank you for what you've been doing.
If it's okay with you, I'll just stand and present. I do a little better when I can move around, if that's all right. So let me see if I can get in here. I recognize that we are, that we're a little bit behind schedule, so I'll try to catch us up just a bit. I do have a few slides that overlap with what Stefan just presented, so I'll try to go through those relatively quickly. My name is Michelle Royal. I have been working since April of 2001 on something called Project Responder. So in the United States, we started looking after the attacks on Oklahoma City at where there are common capability gaps for emergency responders. You have police associations that are looking at gaps in new technologies for law enforcement. You have fire service associations that are looking at that for the fire service. Same with emergency medical services. But there are a number of capabilities that are common across all these responder organizations. Everybody needs communications. Everybody needs logistics. Everybody needs command and control. So we started off in April of 2001 looking at what those common capability gaps might be. Obviously, September 11th happened not long after that, and that kind of changed our focus. Since then, we have had, every several years, a new iteration of Project Responder, where we recognize that there's changes to the response environment, and we then look at what those capability gaps might be. We bring together responders from all over the United States to see where we can find some commonality in these gaps. Sorry, I'm waiting, just trying to get us to the slides.
Yes.
So what we've done is we took that basic framework that we were using in the United States and we adapted it for IFAFRI. Because, as Stefan said, not every country has been doing this for a while. Some were starting from the very beginning. So we took the basics of the process that we use in the United States and then adapted it for all the countries to use to develop their own national capability gaps. All right.
Okay.
So I will get us started if I can remember my slides to, there we go, I think we're good. Or maybe not? No? Okay. So I'm going to try to remember them exactly going on. So Stefan had a slide to start off that talked about the challenge of that IFAFRI was facing. That was that fragmented market that we were talking about. The market is fragmented in a lot of different ways. In Europe, you mainly have one agency that's buying things for their civil protection or their responder markets. In the United States and Canada, it's very different. In the United States alone, there are thousands of agencies. Each are buying their own equipment, each with different priorities, different budgets, things like that. What happens in one city and what they buy may not be at all interoperable with what happens in the city right next door. So there's incredible fragmentation just in the United States and Canada alone, not to mention when you start adding in all these other countries. So one of the things that we were trying to focus on doing is making sure that if you have some, I don't know if they need something else, that if you have all of these requirements that responders can agree on, that you can get some economies of scale. No longer are you just trying to sell to one agency that's buying 20 of something. If you have a product that fits the needs of all of these communities, then you can mass produce, make more of what of what's being bought, and then try to sell it that way instead of trying to focus everything on the exact needs of different agencies.
No,
No.
We need some innovation in terms of presentation facilities.
Okay, yes, we are. And my ability to just randomly talk about this.
I think this will be a top gap in the
Okay.
next iteration.
Yes.
5 more slides.
What else do I want to touch on while we're doing this? Try to bring up, so question of knowledge products earlier. Another thing that we're looking at here is if we are able to identify what all these requirements are, it may not be technologies. There are barriers with regards to training. There's barriers with regards to policies and procedures. All of these things are going to inhibit the development of technology. So even if the ultimate capability is developed, if these barriers aren't addressed, then the technology won't be adopted anyways. Sorry, I'm trying to get us through here. All right, so let me just try to pull this off the top of my head. We talked about the challenges. We talked about what IFAFRI is doing. So we've mentioned earlier the importance of the first responder in all of this development. In the process that we have for the SOOs, we are very focused on bringing in that responder perspective. The SOO validation, the SOO development process is the first to, once we have the capability gaps, is to, first of all, create a draft of the SOO. That's usually done from the IFAFRI staff who come together and we review documents. We review NIST and NIOSH and all sorts of different associations who have come up with requirements or have done studies. We look at other capability gap repositories, other requirements that are available, and come up with a draft of the SOO document. That SOO document is then sent to all the member countries, and they are asked to present that to their emergency responders. In the United States, for example, we have a First Responders Resource Group. It's a group of 150 responders from different disciplines. We send that to our FRRG group, and they review the documents and provide us with detailed comments. There we go, look at that. It is line by line, they can make comments on these documents. In Canada, for example, they have very close association with their associations. So they send them out to their associations who are able to make comments and provide us back with comments. So let me stick through here. All right. There we go. That slide should look familiar. I think I've captured that. Hold it here.
No, just give me a second.
Okay, go ahead. Next slide. Okay, so I'll touch on this before I go back to where I was. What does anybody get out of the association with IFAFRI or with the products from IFAFRI? So first of all, industry and researchers, and this again goes back to your question earlier about the fragmented market, is that we create a source of vetted requirements, gaps and requirements. This is not requirements that one agency or one person from one agency think are important, which happens a lot, but there is a large group of responders from different countries that come together to not only comment on these SOOs, but also help to validate them once we have a better draft. And I'll get to that in a second. Access to operators. A lot of times with these industry days, we will bring in responders, and as we have done today, who are able to answer questions. You can say, okay, you've said that this is a problem. I don't really understand why that is. So you can ask questions and better understand what the responder need is. As we said, they're responder-defined operational needs. We also provide some information, and you'll see here shortly, on market size and trends. And then that provides you with a starting point for technology development. With Horizon 2020, and now it'll be, I believe, Horizon Europe, there is sometimes funding associated with these gaps. The US, Canada, Australia, different countries have different funding mechanisms that because these gaps are aligned with their national gaps, you can oftentimes find funding opportunities or challenges associated with them. The first responders then get more and more innovative technology that is better suited to their needs. helps to make them more efficient, more effective, and more safe, which is very critical. It helps them potentially have reduced costs if you are able to produce things at an economy of scale, so they can get access to better technology, and they know that their voice is heard. Finally, the public. We all get better equipped responders who are better able to help us in our times of need. Next slide, please. So, this is kind of a summary of a lot of the slides before, but what we do is a list of common high priority capability gaps that are consensus. That's a platform for international collaboration. Again, we help characterize that market, and that provides relevant information to all the stakeholders who need it. Next slide, please. Okay. I have 2 slides here that are a little bit out of date. They're out of date for a couple of reasons. Number one, some of the information sources we are using are no longer being updated. And also because some of the information sources that now do exist are a little bit in conflict, so we're trying to resolve that. So I wanted to give you the older slides, which in reality have not changed significantly. But the total number of first responders among the IFAFRI countries is over 7 million responders. Law enforcement is about a third of that. Fire is a little over half of that, and then emergency medical services over 1 million people. Next slide. So all of these agencies then have budgets, right? And you think about the budgets, the vast budgets that are available to these agencies, when in reality, a good chunk of their budgets are taken up by staff. Another part is made up by goods and services. So then we can look at what is the actual budget of IFAFRI countries. The last that we looked at this, we're able to calculate it, is $17.3 billion is the market for capital goods and services, which is used to purchase equipment and other long-term assets. So it helps to think of what that market might be like. Next slide. Okay, so I'm going to talk about the common global capability gaps. Stefan already went through the 10. I'm going to go through them in a little bit more detail. Please keep in mind that if you look at the SOO documents, they're about 10 pages each. I can come up with 20 slides for each one of these capability gaps. I will not put you to sleep today by doing that. You can go and peruse the documents at your leisure. But I do want to talk about what the gaps are and why they exist. So here's the first 5 gaps. I'll go through them individually. Next slide, please. And the final 5 gaps, and I'll go through them one by one. Next slide. Okay, so as Stefan mentioned, we have a process for getting to the national capability gaps. There's 4 parts of this process. I'm not going to go through all of them, where we can first prepare the countries to identify their gaps. Not everybody uses the same process, and no, we don't have to use the same process. As long as what happens at the end is this list of high priority gaps. Each country is then asked to identify their gaps through the process that they use, highly encouraging them again to use emergency responders as part of this process. They validate their gaps to make sure that everybody is in agreement, and then prioritize them. They then send those gaps to the Program Management Office of IFAFRI so we can assess those gaps. Next slide. So for each of those gaps, then we create a statement of objectives document. Next slide. Go back just one real quickly. No, back the other way. There we go. So the purpose is to provide the requirements as articulated by responders to industry. When possible, we have them in qualitative terms, quantitative terms. Often they are qualitative requirements. Next slide. So there's a process, right? For everything, there's a process. The first is the development phase. I started talking about that earlier, where we're reviewing documentation and reviewing requirements. They might come from military, they might come from industry, other commercial areas, to try and identify what these requirements might be for emergency responders. We create a draft SOO, a draft statement of objectives, and again, send that out to the countries so they can have their responders comment. We often have, each country sends back their responses with detailed comments. You need to change this word, or I think this parameter is not correct, and we create a revised version of the SOO documents. We then, as was referenced earlier, have a SOO validation meeting. Again, we're bringing responders in from member countries to look at these requirements from an international perspective and validate the requirements that we have or make changes as necessary to make sure that we have consensus on the requirements that we have. And so then the finalization phase is to take those, any changes that were made in the SOO validation meeting and create a final version of those SOO documents. Next slide, please. Am I talking too quickly? Let me know if I need to slow down. So each document, what does it have? First of all, it contains a general description of the capability need. It's a couple of paragraphs to kind of describe what the issue is and why there is a gap. The next part is a list of current capability. You can't really describe a gap unless you know what the current capability is and where responders want to be. And that delta between those two is the gap. So it's helpful to understand what responders have now in order to do this, this capability. There's a general description of the responder operating environment. This is one section that is consistent. It should be or is going to be the same across all of the SOO documents. It's really intended to help industry or academia understand that there is a very vast set of missions that responders must respond to. What happens in by law enforcement in a desert region and fire service in northern Sweden are dramatically different things, and so you need to understand that equipment or new technologies, solutions that are developed for responders have to be able to operate in a number of different environments. We list some high-level target objectives that are kind of umbrella objectives over the rest of the requirements that describe the capability. Next slide. Okay, so we call this a disclaimer in the SOO documents. A couple things that are really important here. First of all, again, responder identified requirements. This is not a government agency sitting there deciding what responders need. It's actual responders that are telling us what they need. Not all requirements may be technically feasible. Responders have described what they need. The solution to do that may be a little bit more difficult, and I'll give you an example. When we first started doing Project Responder, we asked about self-contained breathing apparatus. The breathing, the respiratory protection that firefighters wear when they're going into a building that has, or an area that has oxygen deficient, okay? So right now, that pack, the whole pack weighs about 40 pounds and lasts under heavy exertion from 15 to 30 minutes. That means they have to go in, do what they do for however long you can get to, 10 minutes, 20 minutes, and then get back out and change out that tank. So if it's 40 pounds and lasts for at most 30 minutes, they said that they were looking for something that weighed 10 pounds and lasted for 4 hours. And the technologist that we had in the room said, no, that defies the laws of physics, that's never going to happen. And so the responder said, well, that's what we want. But yet, all of a sudden, 10, 15 years later, we've got the development of nanomaterials that are helping to reduce the weight. We're not at 10 pounds, anywhere close to that right now. In fact, most responders are still using the heavy metal cylinders. But as technology evolves, more of these things become possible. And that leads to another point here, is that responders would like incremental improvements in capability. We don't have to wait till a company can check every single box on these lists before you introduce something new, because that means it's probably obsolete at that point anyways. Any improvements, if you can go from 40 pounds to 38 pounds to 35 pounds, any little improvement is going to help. So waiting until every box is checked is not ideal. Finally, they do not represent a minimum set of requirements. So there may be going back to what I was saying, if you are a company that can address only one of those requirements, that's great. Make some advancement on that requirement and get that integrated somewhere so that we're not waiting for everything to be done before we move forward. Next slide. All right, the last thing I want to capture before we go into the SOOs themselves is a deep dive analysis. You'll see slides here for each of the SOO documents, where what we have done is for each gap, we have done an in-depth assessment of the capabilities that are available, the technology solutions that either exist or are in development. We look across defense industry, responder industry, and then commercial applications to see where there are products or solutions that may already address some of these requirements. We look at the market itself, try to quantify that market, and then look at the competitive landscape for each of these SOO documents. We have all 10 deep dive analysis documents completed, although the ones for 5 through 6 are in review and will be released hopefully somewhat shortly. Next slide. Okay, so gap 1. The ability to know the location of responders and their proximity to risks and hazards in real time. This is responder geolocation. Responder geolocation seems like it might be not that difficult of a problem to solve. As Stefan has mentioned and lots of other people mentioned, your cell phone has the ability to track you where you're going. The problem is that GPS does not work well going indoors or below ground. And it doesn't do a great job of telling you what your altitude is. So if you think of what happened on September 11th when you had police and fire service folks going into the towers. You don't know if you are on the first floor or if somebody is on the 110th floor. And if you are searching for a downed firefighter, that's a really important thing to know. So not only that, but responders operate over very large geographic spans. If you look at a tornado response, you have miles and miles of response. Wildfires, again. So the ability to know where responders are on the incident scene is very important for their safety. So not only do you need to know where they are, you need to have some sort of a graphic representation of where they might be, and then know where they might be in proximity to any hazards. If you've got a plume that's been released of some sort of a chemical, you want to be able to say, I've got these 3 responders right here that I need to tell to evacuate right now. Next slide. So what do they have right now? Really, very little. Paper tag and tally systems. That's literally a piece of paper that is on some board that says, I have this responder on the incident scene. Sometimes those pieces of paper get lost. Sometimes they don't get updated, so it can be very difficult to figure out who you have on an incident scene. String guidelines, some with lighting. That would be if responders are going, for example, down into a subway system or into a confined space. They might bring a string with them that's lit, so you know where they are. Some land mobile LMR, land mobile radio systems, that's the push-to-talk radios that a lot of responders carry. Those sometimes have a geolocation capability to them. A lot of times that only works best outdoors. And then responders that are based in their vehicles, a lot of times their vehicle will have a GPS system. Next slide. So capability gap 1. What are our 3 or 4 sometimes overarching objectives? The first is that accurate 3-dimensional location of responders on the scene. The second is the graphical display of where they are, we said that. And then third would be integration with situational awareness tools. There's a lot of tools that are out there that either incident command or emergency management is using. You don't want to have standalone systems for all of these different capability gaps. Responders don't want to have 10 screens up in front of them. They want to have one screen potentially where there are different layers that they can turn on and off. In the same way, and we'll get to this, responders don't want to have anything else hanging off of their belts. The more things can be integrated, the better. Next slide. Okay, so for each of these 2 documents, I'm going to explain what the categories are of the requirements. Keep in mind that there could be dozens of requirements under some of these categories, which is why we're not going through them one by one. So obviously for something related to geolocation, we want to have accuracy requirements. If I'm remembering carefully, it's responders want to have geolocation within 1 meter in X, Y, and Z dimensions, for example. Transmission requirements. So first of all, you've collected this data on where they are, but now you need to send it to someone. So how are we going to do that? And how are we going to do that if the network is down? Obviously, responders, as has been mentioned previously, communications is always a challenge. So how are we going to get this information to where it needs to go and who it needs to be delivered to? We talked about the visualization requirements. You want to be able to see where responders are on some sort of a display. And that may mean that there's a user configuration element to this. You may want to have certain colors for different disciplines. You may want to have unit numbers, things like that. So user configuration is a big part of a lot of these requirements. Compatibility requirements. So I mentioned earlier integration with software systems. It's not just software systems. There's a whole list of different systems that responder geolocation solutions need to be able to be compatible with. And you'll see key among this, and many of these, is information exchange. If you have a proprietary system that has a certain set of data that can only be read by your visualization platform, that's not going to work well for a lot of agencies who are not going to be able to afford all of these different systems. Form requirements. This is focusing on, as I mentioned earlier, minimizing the equipment burden for responders. Right now, a lot of responders have a belt that has their radio. It might have handcuffs, it might have a taser, it might have a stick of some kind. Everything that's on these belts weighs a lot and puts strain on the responders. So minimizing the burden for responders is best. Next slide. Alarm feature requirements. So let's say you are a responder and you are, as I said, near that plume. A tanker truck has just turned over of ammonia and anhydrous ammonia, and that plume is coming towards you. There needs to be some sort of an alert function to alert a responder that they are in proximity to threats and hazards. In the same way that there needs to be alarm features that if that responder goes down, someone else is alerted that they are in need of help. Power source. This is a huge issue for a lot of these capability gaps. Power is kind of in some ways the holy grail of what we're looking for, being able to power these technologies. So this is everything from sustainable power sources, being able to use what's available on scene, non-proprietary power sources. If you've got a power drill that's got a Makita battery and you've got a DeWalt drill that's got a DeWalt battery, you can't interchange those. So if you have different response agencies that have different capabilities, they need to be able to swap power sources for a lot of these things. Maintenance requirements. Fairly simple. And what you'll see is, especially the maintenance, the robustness, and the cost requirements. These are fairly similar but not identical across all the SOO documents. The maintenance requirements, it has to be launderable if it's integrated in garments. It has to be able to be repaired in the station. All of these things calibrated in station. They don't want to have to send something out so they're without the capability while something is being repaired. So the more these things can be done in station and by the responder or by the response agency, the better. Cost requirements. We've mentioned it before many times. A lot of response agencies have very little money. You have volunteer agencies that may have almost no money at all. So the importance of not designing these things just for the largest agencies or the largest countries is really important because the folks in the rural areas need to be safe as much as those in the big cities. And that goes for, we'll get to that, consumables and maintenance too. If you have a cheap technology, but the filters that have to keep going in that cartridge cost as much money as the original thing does, then that's really not helpful to a lot of response agencies. Next slide, please. All right, so this is the market highlights for SOO1. So what we've done, again, is we've looked at all of the requirements that the responders identified and looked at the different market segments that most closely align with that. In some cases, there isn't a primary market. In some cases, there were 36 markets that seemed to be related. So when we could, we picked the market that was most closely associated with the gap. In this case, it's the hybrid geolocation market. There are outdoor, like climbing type outdoor geolocation capabilities. There are some indoor geolocation capabilities, but because responders move indoors and outdoors, you need something that works in multiple places. So the hybrid geolocation market is what we looked at. It's an emerging market. Market size as of 2019 is $8.8 billion. Next slide. All right, gap 2. The ability to detect, monitor, and analyze passive and active threats on the incident scene in real time. So active threats, that is the tanker truck that's been overturned already. You know that that's an active threat on the scene. Passive threats, that can be either threats that come from the first threat. If you go back to the tsunami and the nuclear meltdown in Japan as a result, that was somewhat of a passive threat until it became an active threat. The reactor wasn't in trouble until the flooding happened. Another one is weather. So if you are out on an incident scene and you have severe weather coming through, that's a passive threat that can become active, but you need to be able to monitor that to see what's coming your way. So those threats and hazards on the scene can change very quickly. And they may, for example, as a weather forecast, it can get worse very quickly. It can decrease. You need to be able to just monitor what those threats are. So not only do responders need to know, okay, you're in the middle of a plume, but if you've got anhydrous ammonia coming at you, you need to know potentially what sort of precautions need to be taken. You need to know what the standoff distance might be if you're needing to evacuate out of the area. You need to know what medical treatments might be appropriate if you've been exposed. So it's not just, okay, you've been exposed to something, it's providing additional contextual information that's helpful. This is different than gap 3 in that gap 3 talks about the actual identification of what that specific contaminant or toxin or whatever it is might be. This is more a general look at threats and hazards. So it's not just CBRNE threats, it's also things that are moving fast towards responders, or it's gunshots, or suspicious persons or packages, things like that. All of these things are threats to responders on the incident scene. Next slide. A decent amount of gear already exists. There's handheld portable equipment, there's vehicle-mounted equipment, there's a lot of tests that need to be sent off to laboratories. Camera feeds exist for visual identification. All of these different things, I'm not going to read them all to you, exist that responders can use now. However, there is not a lot of capability for detecting things on the incident scene in real time. Bio being a big one of those, but other threats as well. Next slide. So, what are the 3 main objectives for GAP 2? The first is that it detects and monitors continuously on the incident scene. The second is that it assesses the threat and hazard data to provide guidance and decision support. And then third, that visualization capability of the threat location and proximity to responders. So this is one where GAP 2 and GAP 1 would integrate so that you would know where the responder is in relationship to that threat. Next slide. I'm not going to go through all of these just like I did before. I will point out where there are differences. First of all, there's detection, monitoring, and analysis requirements, right? Different than responder geolocation. You need to know where the scenes are, or where the threats are, and monitor them. As I mentioned, those are the different types of threats that were included as part of the GAP for GAP 2. Location requirements, again, we'll go back one more. Yes, these are all quite similar to what we saw earlier. Next slide. Again, similar to what we saw earlier. Compatibility, robustness, and cost. All right, next slide. All right, the market highlights for SOO2. The market that we found that was closest to the requirements described is the remote sensing technologies market. It's an $8.4 billion market. It's quite a mature market at this stage, but is still experiencing some level of growth. One of the things I want to point out, and it's available in the SOO documents, especially for gaps 5 through 10, we did more of a focus on this, where there is the research onto the different technology solutions that were identified. So we could see where there is applicability in other areas. Next slide. Gap 3. This is a very focused gap on identifying the hazardous agents and contaminants. When responders get on scene, they may not know what's there. As we said in the previous gap, that and what's there may change quickly. So the ability for responders to quickly know what threats and hazards they're facing with some level of detail is important. Let's see. And again, how it's different. Yep. Existing first responder gear, a lot of this is the same as what we saw earlier, fixed, mobile, and other sites that are available, equipment that's available. Responders, firefighters can take their 5 gas meter and show up on scene and be able to know where things like carbon monoxide levels and oxygen levels, things like that. But a lot of the equipment that exists today is really not very detailed. There's a lot of common toxic industrial chemicals that responders are exposed to. Law enforcement that might go to a meth lab or some sort of a drug manufacturing site are not going to know what they're being exposed to because of the limits of the existing technology. Dogs can be used for some of these requirements here. And then again, the camera feeds. Next slide. No. Okay, so what are the 3 main objectives for this capability gap? The first is detecting those hazardous agents and contaminants on the scene. The second is transmitting the data to responders in command. There are resources like the Emergency Response Guidebook that provide a lot of contextual information, as I was mentioning earlier, about standoff distances, if you're evacuating other people, where they needed to be evacuated beyond, PPE that needs to be adopted, things like that. That needs to be transmitted to both the responders and command. And then providing that pertinent information to about the threat and hazard. Next slide. Detection and identification requirements. Being able to detect them in real time. Location, alarm, transmission form, those are all the same. Next slide. Power source maintenance, compatibility, robustness, and cost requirements. Let me touch, I didn't touch on it very well earlier, robustness requirements. That really talks about the different types of environments that these technologies or potential solutions may have to operate under. So again, it's weather extremes, climate extremes that different responders are facing. If we're talking about responders and a global market here, we have responders that are in very cold climates, very hot, dry climates. So developing something that only works for a small group is not going to be as effective as obviously developing something that can work for a larger group of responders. That has to work in high humidity, smoke and ash, things like that can be found in the robustness requirements. Next slide. The primary market for Gap 3 is the smart sensors market. Right now, quantified at $18.6 billion market. Again, already in the mature market stage, but with some growth remaining in the projections. Next slide. Capability Gap 4. This is the ability, I want to stress, the multiple and non-traditional sources. So the multiple sources is really the key there. The ability to take information and data from all of these different sources. Responders are already facing data overload, and we're just at the beginning of the amount of data that can be generated for emergency responders. So trying to put that into one common platform where they're going to be able to see and understand what that information is. We have another gap coming up later that talks about creating actionable intelligence from that data. This one is mostly about incorporating that data into operations. okay? I do want to bring up the non-traditional sources. That is a part of it, not the entire thing, but the ability to pull in information from social media or other non-traditional platforms. Let me give you an example of this. There's the Boston Fire Department has a group in Boston. They use Periscope, that as soon as they hear of a fire or hear of an alarm, they can get to a fire before the fire department can, and they will start to live broadcast the fire from Periscope. So as the fire department is en route to the fire, they know what site to use, and so they can get advanced situational awareness about what this fire looks like before they even arrive from a group of citizens that just do this for fun. So again, pulling in non-traditional sources to help with incident operations. Next slide. Existing first responder gear. Responders have access to devices. They have access to different databases and record management systems. There are some commercially available tools that help them do this. However, a lot of times they are cost prohibitive for some of the smaller jurisdictions. And then there's also state and jurisdiction level programs that are available as well. Next slide. The target objectives for GAP 4. So integrating the data from both public and private sources into the incident command and response operations. The ability to incorporate, integrate that data, ingest that data, and validate the data, especially when we're talking about social media or other non-traditional sources, is very important. But it's not just social media. The ability to validate that data. If you have something that comes from a public safety agency, you might put more trust in that than something that comes from a private source, or maybe the opposite. And then the ability to display that data using, again, the user configurable settings. That's really important in a lot of these capabilities, is what works for one agency or jurisdiction or one chief or captain is not the same as that works for either the responder in the field or the captain right next to it. So user configurability is an important issue here. Next slide, please. Data type requirements. There's quite an extensive list of data types in the SOO document, talking about what types of information and data that responders would like to be able to pull from. Again, the visualization requirements are going to be similar to, but have a different result than we saw previously. But the ability to, I mentioned earlier, the ability to use a set of layers. So responders can turn on and off different sets of data to fit what they're doing at the time. Image and video feed requirements. We had a special set of requirements specifically focused on the ability to integrate, transmit, and display those images and video in real time. Data usage requirements, those are different. The ability to do all that and pull everything together when you need it, as opposed to waiting for 2 hours until something can be finally figured out how it can be fit into the mix. Analysis requirements. We touch on this here, but expand upon it far further in the other capability gap. The ability to assess that data. A whole bunch of data is really not useful to anybody, especially if they're in the middle of response operations. So some ability to provide information relevant to that data to responders is important. Next slide. Transmission requirements, compatibility, maintenance, and cost are, again, all very similar across the documents. You can see where there are differences, but those are the categories. Next slide. So the global public safety analytics market is the closest that we were able to identify for SOO4. It's still a growth market, looking right now at a $6 billion market size with a 16% CAGR. Next slide. Gap 5, interoperable comms. This is kind of somewhat the holy grail of emergency response. As part of the work that we've been doing, interoperable comms and data sharing has been one of the highest prioritized capability gaps across different countries, across different years. Billions of dollars have been put into interoperable communications, and yet we still largely do not have it. at least in the United States and Canada. Right now, there's efforts to develop public safety broadband, which can potentially provide significant improvement in this area, but it's not a reality yet. So, communications are essential to any emergency response operation. They must be able to seamlessly convey what they need, be told what to do, request resources. All sorts of information has to be conveyed either by voice or data or video. So the lack of this is a huge issue. Next slide. What exists now? So push to talk, land mobile radios. Those are the traditional radios that you think of that responders carry. Some carry smartphones. A lot of agencies don't allow their responders to carry smartphones. A lot of responders, like fire service firefighters, they're not wanting to put their cell phone in their turnout gear, so they are only carrying the land mobile radio. Some agencies have access to sat phones. Many have access to tablets or mobile devices, especially in vehicles. So for law enforcement and EMS, a lot of them have tablets or some sort of a laptop, hardened laptop in their vehicle. Lots of different frequencies. So even when you're talking about radios, just because I have an LMR and Ron has an LMR, if I'm on 700 megahertz and he's on UHF, we're not able to talk to each other. So even though there are, and we'll get to those, some boxes that can help bridge that gap, the ability for the different systems to talk to each other is limited. Television signal datacasting, that's being used and explored further. Colts and cows, and now there's a new one called on an SUV. I don't remember what it's called. So that's basically a deployable communication system you bring in on wheels to help boost communications on an incident scene. Some use of mesh networks. Those gateway devices are the ones that I told you that are going to help connect the different systems together. Repeaters. Face-to-face communications. Next slide. So GetFlat, what are we looking for? 3 main objectives. Interoperable communication of voice, audio, video, and data among all agencies and responders as needed. Communication through all environments. This is another one, kind of like going back to our discussion of geolocation. If you're trying to go through buildings, you have urban canyons, things like that. If I take my cell phone and I try to get a signal in the middle of downtown of a big city, you're going to have a lot harder time than you are in the suburbs. And again, a harder time when you're out in a rural area. So, and then again, disaster resilient or rapidly deployable communication systems. A lot of incidents will take out communications infrastructure. So if you have things that are more resilient to the effects of disasters, the better. Next slide. All right. Device requirements, communication devices. There's a whole set of, it's not just the phone, the receiver, but it's the infrastructure, the network. Again, network requirements, discussions about the infrastructure, security. Security of communications is a critical factor. So we have a set of requirements that deal with the authenticity, integrity, confidentiality of those communications. Transmission, already been through that. Next slide. I'll skip through these. Again, similar to what we've seen before. Next slide. Global critical communications market. It's a growth market looking at 14 billion right now. Next slide. Yeah, thanks. Okay, so this is the desire of responders to be able to see what's happening inside their incident scene without having to endanger responders. The example I can give you is there was Fort McMurray fire in Canada. Because of the conditions of the fire, they were not able to see what was happening and how the fire was moving. During the night, the fire jumped over a river that they thought was not going to be possible. And so they woke up the next morning to find fire in places that they hadn't anticipated at all. Because of the conditions, they weren't able to use aerial assets to see inside where that fire was moving. So the ability to have a bird's eye view of what's happening inside of that incident without having to endanger responders is really the focus of this gap. All of these different things, smoke, weather, infrastructure, debris, all of these things can inhibit the ability of responders to get inside or to a certain part of their scene, and that's what we're getting to with this gap. This gap is focused on surveillance. It's not focused on doing any actual operations. We'll get to that with gap 7. So, improved situational awareness is really what responders are looking for inside areas of their incident scene that they can't get to. Next slide. So what is available now? Obviously, aircraft earth-based surveillance can be used. There is some use of unmanned vehicles, either ground vehicles or air-based vehicles that have been used. Thermal imaging, sonar, LiDAR, all of these different sources are available to responders at times, but there's still a significant gap in what they can get access to and what they can't. Next slide. Only 2 main objectives for this gap. The first is the ability to remotely capture that information in multiple topographies, and then be able to see what's been captured, right? Next slide. Sorry, I'm trying to get through these. So we have system requirements that talk about the size and configuration of all these different platforms that might exist. Visualization requirements, again, the ability for operators, command, whoever it is to be able to see what's the results. Next slide. Again, next slide. Okay, so no primary market was identified because this is a pretty broad gap. It's not just solved by drones. If that was, we could look at the unmanned aircraft systems market. But because it's not, there's no primary market identified. However, if you look at the number of firms, we did find a significant number of potential applications or current or in development solutions to address this gap. Next slide. Gap 7. Okay, similar gap, but instead of just conducting surveillance, responders want to be able to actually do some of their job remotely. One of the best examples that I can give you came from our SOO validation meeting just a couple of weeks ago. One of the responders talked about if you have big industrial 55-gallon drums, a lot of responders are harmed by having to go over there and open up these drums and figure out what's inside. There can be hazardous chemicals, there can be all sorts of things that can significantly endanger or kill responders because of trying to open these drums. It's an intricate task. It's not just going over there and flipping a lid. So the ability, if you could, to send some sort of a robot over there to perform these tasks would be incredibly helpful. But again, there's gross motor tasks, big pushing, pulling, lifting, doing things in hazardous atmospheres. If you have an area where there has been a chemical plume that's been released and you need to be able to lift something up to rescue someone, the ability to send in a robot that might be able to lift that up, pull that person on board and get away would be helpful. Or in areas where it's difficult for humans to reach, again, if you have collapsed buildings, things like that. Let's see. So one of the things I want to focus on with this is that it's not just unmanned vehicles. There are a decent number of requirements in here that talks about unmanned air, maritime, and ground vehicles. But there are a lot of solutions that may not be a vehicle of some kind. One of the things you'll see next slide, when we get to the current capabilities, there we go, is in addition to the unmanned systems that we've already talked about, there are fixed systems. There's fire suppression. We've got sprinkler systems in here. That does the work of an emergency responder. It puts the wet stuff on the red stuff, right? Without having to bring in the responders. But there's also other monitors and systems like that that can be used to help deploy some of these systems in advance. So while a lot of times the responders are immediately thinking of those vehicles in whatever form they may take, there are also other solutions that are available that can help do, not do the job, but support the work of emergency responders. Next slide. So 3 main objectives. is providing the appropriate ability to carry out the mission that they need to do, operating in hazardous conditions, and then in a beyond the line of sight capability. A lot of the capabilities that exist right now are things where you still have to be pretty up close in order to move your vehicle around. So the ability to do that from a much more standoff distance, and I believe Max, one of the UAS systems that are out there, is going to be operating from hundreds of miles away. Is that correct? Yes, so that's something that you guys will be able to see in the technologies outside. Next slide. Next slide. Next slide. All right, again, no primary market identified, very similar to the previous one because of the diversity in the potential solutions that are available. Again, a large number of firms and solutions available though. Next slide. Gap 8, physiological monitoring. So this is not something that really exists for responders right now. You have athletes that are able to wear their Apple Watch or their chest strap or whatever it is. Astronauts in space have physiological monitoring, but this is really something that does not exist very much for responders. There are a lot of demands of the missions that can adversely affect their health and their mental cognitive capacity. So if you have responders, we talked about the 40 pounds, that's just in the SCBA, plus they have belts, plus their turnout gear. A lot of times responders are wearing 50 to 60 pounds on their body. If they're climbing up stairs to try to get to a fire, that's physical exertion. So you have a lot of problems with responders with health effects, not just of anything they're exposed to in the incident, which given the new plastics and materials that are available today put off a lot more different gases and toxins that were not available 10 to 15 years ago. So responders are exposed to a significant number of hazards during the time that they are operating and in the hours afterwards. A lot of the heart attacks that happen with firefighters, for example, happen in the hours after they've come out of a fire instead of right there in the middle of it. So monitoring those types of things, their physiological signs and symptoms and their cognitive indicators is one way to help identify where potential problems might be. Next slide. So what exists right now? Physicals, they get those maybe, hopefully, once a year. A lot of times there's on-scene checks, but that's usually if they've seen it's a longer incident, not for some of those shorter incidents. A lot of firefighters carry, what in the US are called pass alerts or pass alarms. In the UK, I believe they're ADSU alarms. So that can tell you if the responder is down in a horizontal position, but not tell you anything further than that. And then some responders are able to, for personal use, wear things like Garmin or a Fitbit or whatever it is to help provide some indication. Next slide. So, what do we want to be able to look at here? The first is the persistent measurement of those physiological data to detect threats to the responder. Examples are given. But again, I want to focus that this doesn't just talk about physiological signs and symptoms, but also cognitive behavior and indicators as well. Assessment of that data against responder-specific parameters. This is really important. I have relatively low blood pressure. My husband has relatively high blood pressure. If you were to look at a blood pressure reading, comparing it against me, it might be a really bad number, whereas for him, it might be pretty normal to what he normally has. So the ability to compare the measurements that are taken against baseline information for that responder is really important. Being able to provide operational and health-related guidance based on that data. So if you have a reading that's showing that there's a potential issue, it may not be enough to call somebody out of the building, but it may be, say, you need to check in with medical check as soon as you get out of the building, or whatever it might be. But being able to provide, again, that contextual information, not just the data. If you just, again, a reading that shows that your, pulse ox is something, or your heart rate is something without some sort of contextual information, that can be useless data. And then integration of all components, when possible, into PPE. Again, already responders are carrying a lot of weight. The ability to minimize that weight is incredibly important. Next slide. The only thing that's different here are the monitoring requirements, talking about what sort of data is going to be captured and how responders want to have that captured. Alert requirements are similar to what we've seen before, but not exactly the same. Next slide. Next slide. All right, so again, no primary market identified for 8. Still a large number of firms, but because there is a wide variety of different capability available right now, or solutions available. Next slide. Gap 9. Okay, so we talked earlier about the integration of data from multiple sources. This is the ability to create something out of that data, actionable intelligence. You have all sorts of information that's coming towards you, the ability to figure out what to do with that information, whether it's checklists, templates, decision support, anything that can help responders make sense of all the incredible amounts of data that are available to them, and more coming at all times. So a lot of data is generated, but not a lot of contextual information, which isn't helpful. If you will look at, as a small example, if you look at a Twitter feed, for example, the Las Vegas shooting, if you look at just the Las Vegas Police Department or the Las Vegas Twitter feed, following that, things scroll so fast that a human eye cannot keep up with how quickly those tweets are coming in, just dealing with one incident. By the way, a lot of that information completely incorrect, so how is a responder who's getting all of this information overload supposed to figure out which information is valid, which is not, which is helpful, which is not? So, this gap is focused on the ability to take all of that data and put it together to make something useful for responders. Next slide. How does this happen right now? There's task forces, different cells, things like that, different analysts within agencies. There are some models, like Plume models, that currently exist. And then some data integration and support tools that are available. Again, some limited due to cost. And then things like computer-aided dispatch systems. CAD systems do provide some analysis of the information. Next slide. 4 target objectives. The first is providing the user with contextual information. Assessing both the incident-specific data and legacy data. It's really hard to determine patterns. For example, if you're doing pattern analysis, if you don't have access to previous records, for example, of robberies in that area, the ability to access historical data is also very important. The provision of forecast models, and then decision support tools as well. Next slide. Let's move forward. Again, data type, long list, you'll see it in there. Move forward, please. So, again, the global big data analytics market is what we identified for this. $14 billion market with a 29% CAGR. Again, very much in the growth phase for this market. Next slide. Finally, gap 10, almost done. PPE, the ability to provide advanced and appropriate PPE for the incidents. So the purpose of this clothing is to protect responders when they're doing their missions. A lot of times the garments themselves are not incredibly helpful for that. If you look at both law enforcement and emergency medical services, generally all they wear is a duty uniform. In a lot of cases, that uniform is made of polyester. Unfortunately, when exposed to high heat, polyester melts on the body. So it is not a safe material for a lot of responders to wear, but given its price point, it's incredibly cost effective. So responders are exposed to all of these threats and hazards, but yet they don't necessarily have the garments or any equipment that's going to help them, help to protect them. So duty uniforms, again, provide limited protection. Turnout gear is, that's like your firefighter gear or ballistic vests, things like that, can be heavy and add to the physiological stress on responders. And then respiratory systems themselves, that's either the SCBA we talked about earlier, or if you have oxygen available, it could be a mask or a PAPR, a powered air purifying respirator. Those have drawbacks as well. So responders are looking for garments and equipment that's going to help protect them better. Next slide. There's a lot you can see here. I won't go through all of them in the first responder gear. There's duty uniforms, there's vests, there's helmets, there's boots, there's all sorts of things, hazmat suits that responders wear currently to protect them. But again, there's drawbacks to each. One thing I do want to point out that for this suit, we have not covered fire service helmets. There are dramatic differences between the fire service helmets that are used in the United States and used by the rest of the world that adopts technology. And so we did not include firefighter helmets in here because we were not able to get a consensus on those helmets, although hopefully the United States is starting to move towards safer and more effective helmets. Next slide. 3 objectives. The first is garment that protect responders against the most likely threats. If you can have a material that's got limited levels of chemical protection, for example, or even some sort of a sensor that says when they've been exposed to a chemical. If you've got slash resistance built into basic duty uniforms, things like that, are all going to help responders doing their daily jobs. The sheer number of emergency medical personnel who have received cuts from things in people's beds or needle sticks because the needles will go right through their uniform, it's a problem. So next one is comfort, readability, and durability. You can get a level A hazmat suit that is going to protect you from a lot of these things. However, you will lose like 80 pounds a minute in how hot they can be. Incredible stress on the body when you're wearing those types of garments. So responders want to combine improved safety and protection with still the ability to move around, the ability to move their fingers, and the comfort of those garments. And then respiratory protection, lighter weight, longer duration, lower profile. Next slide. So requirement categories, we have a whole set of duty uniform requirements, followed by mission-specific garment requirements. The ideal here would be that it's a system where the mission-specific garments build on the protection already provided by the base uniform requirements. A set of respiratory protection requirements, and we've kind of captured those both for an oxygen-deficient atmosphere, where you would need an SCBA, and an oxygen-available atmosphere, where you might use a mask or an air-pure or a respirator. Compatibility requirements here are a little bit different. We're not really talking about data integration or software systems. We're really talking about the ability for the pieces to work together or work with other pieces of equipment that responders are carrying. Next slide. Maintenance and cost. Next slide. All right, this is the market for SOO-10. It's the global personal protective market. Definitely a growth market. Right now it's a $45 billion market. So there's a lot of opportunity here. Next slide. All right, so we can skip this. Next slide. Okay, so that is an incredibly quick and dirty overview of 10 SOO documents. I think all the documents are currently available on the website, so you can go and get into all the detail that you would like on those. And again, if anybody has any questions about anything in there, don't hesitate to either ask me while we're here or get in touch with anybody on the IFAFRI staff. Does anybody have, I don't want to take any more of your time. Does anybody have any questions?
I'm Steve Kaufmann from the Defense Procurement in Switzerland. It's a very impressive work you're presenting us here and very useful for industry. Is there any information you're giving about emerging solutions? Let's say emerging solutions for first responders?
So as part of the work that we did for the deep dives is we looked into those emerging solutions. So yes, we tried to capture that in the deep dive documents. Again, first 5 through 10 those haven't been released yet. But yes, we absolutely tried to look in R&D solutions to see what was in development right now that might be helpful and try to capture that in the deep dive documents.
But we will not publish this.
They will be soon. Yeah, the deep dives for 1 through 4 are on the website, yes.
maybe I don't need to use micro. My name is Marian Kolosik. I come from International Security Emergency Management Institute. I think that this is a really great job you did. There are many valuable data that can be very, very useful. Maybe my question will be very, very specific, and to discuss it later, or maybe it will be interesting for somebody else as well. In terms of gaps related to CBR and detection, and PPE, because this is connected to your almost last sentence that you used, that we can use the E level if you don't know the threat. But of course, when performing the task, it's very, very difficult. For example, when collecting evidences from crime scene, you cannot simply do this, or you can, but very in high difficulties. So my question is related to how deep did you go when asking relevant stakeholders or searching for collecting data in terms of detection of CBR and camouflage? I don't know whether you have heard these terms, because many CBRN agents have specific characteristics, and they can hide the other agents. And in case of intentional criminal act, because we never know whether this is at the beginning, whether this is an accident or intentional act, we need to detect the threat in order to perform response. But if this is intentional, and if the terrorists know how to hide some agents by another agent, so they can commit the crime with one agent and prepare the booby traps, CBR and booby traps, some delivery system fulfilled or targeted to first responders. And of course, we go there to detect the threat by in A level. But if we detect, okay, this is this agent, I cannot provide the data. We did some study on this, but this is classified. But if you detect one agent, and then you decide, okay, we just downgrade the level A to level B, we go there, and only after that some delivery system is triggered and is launched, and the first responders face the new threat. Because we didn't detect it in the first phase.
Yes.
Because they know, the perpetrators know how to hide the characteristic of some agent. So did you go in those details to search for some detection devices for future solutions for those details or not?
So no, but that's one of the things that has come up in our need to both regularly assess what the gaps are and then revalidate what the requirements are, because as we've seen, as we've done the different iterations of Project Responder, not only do the gaps change, but as technology advances, so do the requirements change. So as there's greater awareness and understanding of things like the camouflaging agents, that needs to be reflected in documents that we've done previously.
Yeah, because we have some cases already which are really very hard to deal with, and this is one of the challenges that we face. And another challenge is using UAV or ground or water vehicles by terrorists or by perpetrators, because the detection is as well very difficult in moving objects, and especially when they are able to hide some agents by specific cover, which is also one of the requests from first responders to know how to detect those threats.
Yes, absolutely.
Okay, thank you.
What I wanted to add is that what we've not mentioned, and that is an underlying thing, is the legal implication of some of these solutions. Just because you can do something doesn't mean you're allowed to do it. So that's one thing, and the other one is societal acceptance of technological solutions that are being used by first responders. So every time you're using a camera, every time you're collecting information on a first responder, are you actually allowed to do this? Do you need basically someone to accept that they're being monitored, these kind of things. So you need to keep that in mind. Just because a technological solution is bringing the solution to what we want to be able to do, doesn't necessarily mean we're allowed to do it. So we need to keep that in mind. I just wanted to add that to all of the gaps that we are describing in my text.
It's a great point. And the last section of every SOO really talks about that it has to comply with the laws and regulations of the countries that are adopting this technology. So, sir.
One last question because we're running out of time.
Okay, I'll be short. So thank you again, great work. So my question relates to gap number 5. So we are running the Broadway program in Europe, so we have a pan-European mobile broadband public safety, so we're running pre-commercial procurement from 11 countries, small job, yeah. So of course we talk a lot with First United States and so on. My question is really about the market data and where it's sourced. Is it coming from pre-existing studies, or are you doing some of that yourself, or what? Because my concern is there is a recent market study which our team were a little bit concerned about because we were never asked the question. So we're wondering where the figures were coming from. So there's a bit of a trustworthiness issue with some of the market data.
Yes, and they're coming from pre-existing sources. We're not assessing that ourselves. For the most part, usually we're taking information from other sources that have been vetted to the extent possible. Where
okay, thank you. Because what it's quite important to us as we plan forward, so we do pre-commercial procurement and then hopefully the final system. It's very important to understand what we really are. It's quite sensitive.
the data, the deep dive documents are many pages long, so you'll find a lot more detail in there.
Perfect, thank you.
So I would like to thank Michel for this extensive and very thorough presentation. I think among other, it really has provided an understanding of the complexity of the work that has been conducted to finally arrive to define what the requirements really are and what the gaps are. So very, very grateful for it, and I think it is an extremely solid building block for any capability development. So thank you, Michel, and round of applause.